Okay, FRQ 7 here, answer key. There were only 2 of these because I knew this fell really close to our accumulation day, so I made sure to only do 2. This first one came from 2016. It was a non-calculator one. Now, Part B for this particular year is not one you will actually have to worry about. The volume part that comes from our Unit 6, which, as I mentioned in the accumulation video, our Unit 6 is for all intents and purposes College Board's Unit 8, which is what is being cut for this year. Now, as I said in the accumulation video, I do want to be clear, we're talking our Unit 6, not our Unit 7, because we did like a Unit 6, Unit 7 combo unit, right? So Unit 6 was the area, solids of revolution with big R, little r, cross sections. And now with area, it's specifically area between 2 curves. You could be asked to find area on the AP test this year. You could, like with like FF prime graphs, knowing how to evaluate an integral using a graph, knowing that an integral is area, integral is a total that way. Like that could be on the AP test. I do want to be very clear about that. We are talking specifically the area between 2 curves as shown in 6.1. 6.2 then, like I said, was the big R, little r. 6.3 was cross sections. As I said, for all intents and purposes, that is College Board's Unit 8. College Board's Unit 8 has 12 lessons in it for AB, 9 of which come from 6.1, 6.2, 6.3. Again, our Unit 7, those concepts could still be there. Particle motion is contained within College Board's Unit 4. L'Hôpital's, I think, is in Unit 3. I'm not positive about that, but I know it's not Unit 8, which is the important part. Slope fields, differential equations, right? Like so those units, our Unit 7 topics could make an appearance, potentially speaking. Might not. Again, you only going to have 2 FRQs, but could be. Okay, so just Unit 6, right? And if there are questions on that, email me. I don't want you to not study something that could be on the AP test. I'm more than happy to kind of direct you or help clarify for you if there are questions there, okay? But I went ahead and still assigned this one because I liked Part A and Part C. Even Part B has a good kind of reminder because while you might not need to worry about the volume component, being able to evaluate an integral could be something you might need to know, and so it gives us a chance to practice that as well, right? So there are still things in Part B that we could use with the review, could use the reminder of just in case, but the overarching concept of Part B, you don't have to worry about, okay? So taking a look here, we have the inside of a funnel with height 10 inches, has a circular cross section, or has circular cross sections as shown in the figure above. We see our circle here, there's our radius, there's our height. At height h, the radius of the funnel is given by this function. Right, so there's our r function, where h is between 0 and 10. The units of r and h are inches. Okay? Okay, A, find the average value of the radius of the funnel. Now, in terms of the AP test, there are some applications of average that are contained within their Unit 8, but not all applications of average. So it is important that we remind ourselves of how to find an average of something, because, like I said, not all of average has been cut. Okay, so average again is 1 over b minus a, so that's my 10 and my 0, times the integral from a to b, and then the average whatever follows is what goes inside of the integral. In this case, it's the value of the radius, so the average radius goes in. And so I'm literally just putting in my 1/20th 3 plus h squared, that's my radius there. If it was average rate of change of the radius, a rate, remember, is a derivative, so then we'd be doing 1 over b minus a times the derivative of r, and that's what would get put inside the integral. So I think there was one of those in the accumulation video, if I remember correctly. Although if you can't find it, let me know. I'll find exactly where it is if you want to see an average rate of change as opposed to an average value, okay? And so then integrating this, we have our 1/10. You have a choice to make here with our 1/20th. We could, because that's a coefficient, we could pull that 1/20th out with the 1/10 if we wanted, or we could distribute it in. I myself am going to distribute. So we have 3/20, or you could just let it hang out for that matter. Just as long as you don't lose it, you're good. Right? Make sure it's there somewhere. Okay, and so then integrating, we have integral of 3/20 is just 3/20 h. And then back here, adding 1 to the exponent, we'd have h cubed. Dividing that by that new exponent would be dividing by 3. So the 1/20 would become 1/60. And then we have plugging in the upper. So we have 3/20 times 10 plus 1/60 times 10 cubed. Minus, plugging in the lower is going to be 0 plus 0, which is 0, so I'm not going to write it. And then I would leave it alone, right? There's no reason. No reason to go any further. Remember, you don't have to simplify. As long as you've evaluated, you're good. So you don't have to simplify. If you did simplify, this would result in 109 over 60. Yeah, 109 over 60. But again, it's a waste of time, and if you make an error, you've now lost your answer point. Okay? This one this year was worth 3 points. 1 point came from the integral, so knowing how to set up an average, right? 1 point came from the antiderivative, which was actually doing power rule. And 1 point came from the answer, and as we've said in each of the videos, it is possible to earn partial credit if you make a mistake earlier on, but you keep doing the problem correctly based off that mistake, you will still get the rest of those points. As long as you haven't oversimplified the problem, which again, I've got 2 more videos to say this on before your AP test. It gives support to the idea that if you get stuck, do something, right? Move on. Maybe you've set up the problem and you're like, I don't really remember exactly how to take the integral. Well, give it your best shot. Take an integral. Take an integral. Apply a rule to it. Give it your best shot. Make sure you aren't just like making it x cubed for no reason. But give it your best shot. Move on. Plug in your upper minus plug in your lower. You can still get your answer point even if you messed up on the antiderivative potentially, right? So don't let it stop you, right? Okay, put down anything you can think of related to the problem. Okay, part B. Find the volume of the funnel. So we've got here circular cross sections. So this one, for most students this particular year, part B was the hardest part because to have circular cross sections is not something that I would say was super common or is super common within our typical problems here. So we're used to putting our formula into like an equilateral triangle or a semicircle or something like that. This particular year they did put it into the circle. So we have area formula for a circle is pi r squared, right? And then in this case my r, they actually helped you out a little bit with this one and gave you what r is. Okay? And so again, as I said at the beginning of this video, that element is not something you need to worry about for this particular year's AP test, so yay. And so if you wanted to disregard that piece, that's fine. But the reason, like I said, I wanted to still assign B, despite the fact that I know volume is not something necessarily you will have to worry about, evaluating an integral could be. And so we want to remind ourselves of, well, what would we do if we had to, for some reason, evaluate this integral? Okay? Well, if you had a graph, you might potentially look at areas or something like this, but we've got an equation here that we can actually do. And so for me, like this looks really ugly. I myself don't really like working with that. And so I'm going to do a couple of things here to clean this up a little bit. So I've got my pi here. I'm going to go ahead and square this. So the square of 1/20 is 1/400. And then the square of 3 plus h squared, I'm just going to write that really quickly so we can see what we're doing. And I'm going to FOIL that out myself. Okay, so this is a pi over 400. And then FOILing that, 3 times 3 is 9. we have 6h squared from our outside and our inside, and our last is h to the 4th. Okay? And that's where I'm going to do the integral, because I'm a little bit more comfortable doing an integral at that point than back here. You would have to do some sort of UDU or something like that. Honestly, I don't even know what UDU is possible. There might not be one because there's chain rule here. And remember, there's no product, no quotient, no chain within an integral. So you would have to do something to manipulate the integral. And mine's not the only way. It's just a way. Okay? You also have a choice to make here, again, similar to the 1/20th up here as to what you want to do with this pi over 400. It is a coefficient, so I could pull it out all together. I could distribute it in if I wanted to, or I could let it just hang out. Because in part A, I chose to distribute. In part B here, I'm going to choose to let it hang out. That way, whichever way you prefer, hopefully I've hit or demonstrated that particular way. So again, they both work. It's just choosing. So I'm going to let this pi over 400 just kind of hang out here. Because again, it's coefficients. I'm allowed to. Integral of 9 is 9h. Integral of 6h squared is 2h cubed. And integral of h to the 4th is 1/5 h to the 5th. And then plugging in our upper minus plugging in our lower, we have 9 times 10 plus 2 times 10 cubed plus 1/5 times 10 to the 5th. And then it would be minus plugging in the 0, but plugging in the 0, we have 0 plus 0 plus 0, which is just 0, so I'm not going to write it. And then I am going to call it good there, because again, one more time, you don't have to simplify, right? If you did choose to simplify in this particular case, it would simplify to 2209 pi over 40, as you can see in the rubric that I uploaded as well. Okay, this one was also worth 3 points. Like I said, it was this particular year, for most students, the hardest part, because some students did get stuck on that setup piece. Again, nice thing about this year, you don't have to worry about volume with the setup, but I am going to reiterate again, make sure that you don't let the start of the problem completely throw you off. Even if you read part B initially and you're like, oh, I don't know, well, go on, do part C and come back to part B and do something, right? If you are sitting there going, I don't know, again, volume's not going to be on there specifically, but if you are reading something, you're like, that kind of sounds like a total of some sort. Well, then a total is an integral, and so take an integral. See if you can snag some of the later points by taking an integral of something, right? You might be able to snag an antiderivative point or an answer point or some sort of justification point. If you know any relationships as you're reading the problem, write down those relationships, write down those definitions. Again, especially on the hard parts, anything that you can think of that in any way connects you to the problem is a fact that you know related to a vocab word or whatever, put it down. And then don't let it throw you, move on. You're going to have parts of this year's AP test that are going to be challenging. College Board has said that. You can't let that throw you. Okay, the other 2 points are same as above. 1 for the antiderivative, which is actually applying your power rule, and 1 for your answer. Again, with partial credit available. Okay, last part, we have the funnel contains liquid that is draining from the bottom. So draining, I'm already thinking some sort of negative idea. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing, so this is negative, at a rate. So radius is rate, so we're talking dr dt here, of 1/5 inch per cube. Now it is decreasing, so we do need to make sure we make that negative. Inch per second. At this instant, when, again, h equals 3, let me go ahead and write that down as well, 3 inches. This instant, what is the rate? So a ddt, rate of change of the height. So what is dh dt of the liquid with respect to time? Okay? Okay, so we're looking for dh dt. We have dr dt and h. We also have our equation up here. R is 1/20th times 3 plus h squared. Okay, So taking this derivative, actually before I take the derivative, I'm going to go ahead and distribute that 1/20th in. So it'd be 3/20ths, 1/20th times 3 is 3/20ths, and 1/20th h squared. Okay, now I'm going to take the derivative. So derivative of r is dr dt. Back here, that's a constant, so derivative is 0. 1/20th is coefficient, so I'm going to let it hang out, and the derivative of h squared is 2h dh dt. Okay, which then plugging in, dr dt is negative 1/5. 1/20th and 2 are 1/10. H was 3 dh dt. Okay, which then dividing by a fraction is the same thing as multiplying by its reciprocal, so we'd be multiplying by 10/3. Okay, and then again, you don't have to simplify it all. You are allowed to leave it there, or you could go ahead and combine this and simplify. Negative 1/5 times 10/3, the 5 and the 10 would cross simplify, right? So 2, if I were to cross simplify this 2, so this would be negative 2/3 for my dh dt. But again, one more time, you do not have to simplify. You are allowed to leave it. Okay? This one, final one, was also worth 3 points. 2 points were for the derivative process. So taking the derivative there, and 1 was for your answer, which with, again, potential for partial credit. So if there are questions on there, please feel free to email me and ask. Okay? Okay, second one, our accumulation one here. So as I mentioned in the accumulation video, there are elements of this type of problem that you won't need to worry about for this year. As I mentioned in the accumulation problem, every single one of these problems I have back through 2010 is a calculator problem, and as we all know, this year's AP test, you will not have to use your calculator. You will be able to, but you will not have to. And so that fundamentally changes a lot of how we approach this type of problem. I considered cutting it all together, but then decided, you know what, it gives us a chance to review, especially vocabulary stuff, as well as I said in the video, to practice not letting a hard problem throw you. You're going to have hard problems, hard parts of problems, and you can't let that throw you. As we walk through this, I will kind of try to highlight bits and pieces of it, especially that I could very easily see show up on the AP test, bits and pieces of it that wouldn't show up for this year, and again, feel free to send me emails if there's anything that I don't specifically say yes or no on, and you're like, well, I don't know, would this be? I'm more than happy to clarify that for you, right? Okay, so we have people enter a line for an escalator. So we're entering at a rate modeled by the function r. Okay, and the function r has kind of 2 different parameters here between 0 and 300. We use the above function, this complicated looking one, and when t is greater than 300, we use 0. Okay? Where r of t is measured in people per second, t is measured in seconds. As people get on the escalator, they exit the line at a rate of 0.7 people per second. And then there are 20 people in line at t equals 0. So when we did the accumulation video, and actually even before that, the very first Monday's FRQ focus day was a tabular data one. And I talked about the idea of knowing that when something enters, it's a positive rate. When something leaves, it's a negative rate. And so what's inside is that positive minus the negative rate, or taking away the rate that is exiting. And so I myself always typically do this with some sort of depiction. So here's my line, my fancy people. Okay, and so I like showing what I'm kind of thinking here, which is they are entering the line at r of t. So this is my entering rate. They are exiting the line at 0.7. which means those who are in the line, the rate of in line is r of t minus that 0.7, that's what would be in the line at that point in time. If 7 went in and 1 went out, well, then there'd be 6 in line, right? And then how many people are in line is how many were already there. There were already 20. Then the total of those who entered, remember total is an integral, minus the total of those who left. Okay? And again, I did several of these in the accumulation video. I always like depicting it. Okay, so A, how many people into the line for the escalator during the time interval? So how many is our total? 0 to 300. We are entering the line, so that's just my R of T. And then, as I said several times in the video, this actually, you wouldn't need to worry about this for this year's AP test, where you might be asked to evaluate an integral. Don't get me wrong. You could be asked to evaluate an integral. But for example, like this particular R of T getting plugged in here, I don't even know how I would evaluate that. I wouldn't want to, right? To evaluate this integral by hand, we would have to FOIL this out 7 times and then distribute the cube of this into whatever the FOILed 7 times element is, and then do power rule on it. Like that's not going to happen, right? And so you wouldn't have a function like this, for example, on this year's AP test. So where you might need to be able to integrate, and that's again why we reviewed several integrals in the previous problem to this one, it wouldn't be this function, right? This one would definitely be calculator, which is why it showed up on the calculator portion of that test. Okay, and so then you'd pick up your calculator. I've got all these plugged in already so you can see what it looks like. And then as always, if you don't get that function when you plug it into your calculator, send it my way, I can check it. So we plug in our 0 to 300 of our R of T function, and we get 270 as our answer. Okay. Okay, part B. During the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time t equals 300? So in line, this is the number of people in line. We started with 20 already. And then some amount, the total number that entered, right? So the total that entered from 0 to 300. Minus the total that left, the 0.7, would be how much is in there. And so for example, I could see you being asked to evaluate this integral, 0 to 300 of 0.7 possibly. I don't know, the 300 gets a little bit big, but being able to integrate 0.7, I could see that be a non-calculator. And so maybe because we've already done this one and used our calculator to evaluate 0 to 300 of R of T, maybe you, instead of using your calculator on this one, you want to practice doing this by hand, just in case. Gives you a chance to practice another integral, right? And so go ahead and pause the video if you'd like to do that, or you could think through how you would do it if you wanted as you watch the video. The integral of 0.7 would be 0.7t. And then plugging in your upper, so 20 plus 270 is 290. Plugging in your upper, you have 0.7 times 300, which again, we don't have to simplify, so 0.7 times 300, minus plugging in our lower, which is going to be 0, and then I wouldn't simplify, I'd leave it there. If you did simplify, you'd get 290 minus 210, which is 80. I'll write that since I have some extra space. Okay? This one was worth 2 points. 1 point was for considering that there was a rate that was being removed from the line, considering that there was a minus 0.7. So again, that supports that idea. For any problem that you are stuck on, write down anything you can think of related to the problem. Maybe you're sitting there like, I don't know, you read this problem and you're going, I don't know how to do this one, but so let me talk about what I know. How many people are in line? Well, I know there are 20 people in line already, and I know that that would increase as R of t passes, because R of t is the number, right? Like, you can talk through writing, although I would save that for the end of the problem, any extra time you have. But again, put down anything you can think of related to the problem, okay? And then 1 point was for your answer. Okay, part C says, for t greater than 300, what is the first time t that there are no people in line for the escalator? In my personal opinion, I think that's the hardest part of this problem, so I'm actually going to skip part C for a bit here, and I'm going to go to part D next, because if this was my problem, I would do that. Part C, while I will walk through it, and it ends up not being, I would say, crazy out there in terms of understanding, it is, like I said, in my opinion, one of the harder parts. Okay? And so then we come to D, we say for 0 to 300, at what time t is the number of people in line at a minimum, to the nearest whole number, find the number of people in line at this time, justify your answer. Okay, so part D, elements of part D I could definitely see being on this year's AP test. Being able to find a minimum comes out of our unit 3, or a maximum, knowing how to do that in different contexts. Now with this particular function, but it wouldn't happen, right? You need a calculator for this particular function, but being able to know what those steps are comes out of our unit 3, could be there, and so it is valuable to walk through part D to remind ourselves of kind of the steps of finding a maximum or minimum. Because as you've seen over the course of all of the different videos we've done, there's quite a few partial credit points that you can earn from being able to essentially articulate the steps of maxes and mins and being able to model them, okay? So first things first, how do we find a maximum or a minimum? Well, we set our derivative equal to 0, okay? And in this case, it's the number of people in line, and so in line's derivative is R of t minus 0.7. Remember, entering the line had a derivative of R of t, exiting the line had a derivative of 0.7, so in line is entering the line minus those who left the line, so R of t minus 0.7. And so we take the derivative and we set it equal to 0. And even if you just wrote that piece down, considers that the derivative has to equal 0, you just earned a point. And so I've said over different videos, I always recommend at least doing that step. And if you have the time and feel like you're comfortable doing so, well, then you might also figure out like what values of t would make that derivative equal 0. Again, this one is going to be a non-calculator year, and so like I said, this would not be the function you'd be expected to do this on. But modeling, especially because you will be able to use your calculator, so it's handy to remember that if you can get anything to equal 0, you can plug that into your y equals, graph it, and then calc your zeros, right? Second calc or F5, or whatever the case may be, 0, and you could walk through calculating your zeros. Okay? And so for this particular one, you would find 2 zeros, one at 33.013298 and one at 166.574719. Okay? We have an additional advantage, which is, oh, by the way, you got a point for identifying this particular t, the 33 value of t. Because as I was about to say, we have an additional advantage, which is we know we're trying to find an absolute minimum. Well, looking at our derivative graph here, we already know that that point, that 0, will not be the absolute minimum. Because that point, which is where my first derivative changes from positive above the x-axis to negative below the x-axis, is where a relative maximum occurs. Right? If we were looking at a derivative graph, that's a relative maximum. Well, if it's a relative maximum, then it's not an absolute minimum. They're directly contradictory, right? And so you could actually ignore this value altogether if you wanted, okay? Which is why you got a point just for identifying this one value, okay? And then as I said over different videos, I myself usually get to that point And then I go back and I do the other parts and I finish out my absolute maximums and absolute minimums at the end of the time, or after I get stuck, whatever the case may be, because the last steps you usually only get 1 or 2 points. This particular year there are 2 more points available, and it's a lot of work for only 1 or 2 points. So while I want to earn those points, I don't want to spend so much time doing those points that I miss out on potentially faster, easier to get points, right? So again, don't leave it blank, come back to it, but I myself always kind of move on and come back, right? Spend any extra time I have at the end. Because the last thing you do is now have to take the values you've identified as zeros, as well as your 2 endpoints, which for me are 0 and 300, and you have to plug them into your original equation, which for inline, which is again what we're considering, is this 20 plus the integral, etc. And so I'm going to go ahead and do that. People in line at t equals 0. They told me that. That's 20 people. Okay. People in line at t equals 300. I actually found that up here. Right? People in line at t equals 300 was 80. If for some reason you made an error up here and didn't get 80, but you used your number down here, and that somehow gave you the wrong answer because you had the wrong answer to begin with, you wouldn't double lose your point, right? You've already lost the point up here if you didn't get 80. You wouldn't lose it again down here if for some reason your wrong answer continued to lead you down the wrong path, right? Just for the record, for partial credit. And then people in line at t equals that 33 value would be 20 plus the integral from 0 to 33.013298 of my r of t minus 0 to 33.013298 of my 0.7. Okay, which is, and I'll go ahead and show this because I also have this worked out already. So I did it in pieces within my calculator. You also could plug it in all as one if you wanted to, but I did the r of t piece. So I did that middle integral, got 6.9 yada. Then I added 20 to it for that plus 20 out front here to get that 26. And then I myself did like a pseudo integral here. So remember the integral of 0.7 was 0.7 times t. But now instead of 300, we're going to have the 33 up here. And so I myself just did minus the 0.7 times my t, the 33. Let me actually show why that works. So the 20 plus the 6.91274, right, this value here, the integral that I evaluated. And then I did integral of 0.7, which is 0.7t. And then plugging in the upper, you'd be multiplying it by 33.013, right? Minus plugging in the lower is minus 0, so it's not there. And so that's why you generate this 3.8 value. Okay? And so then answering, oh, by the way, all of that work was 1 point. It's called justification. Answering, so at what time t is it at a minimum? It'd be minimum at t equals, well, so of all those values, 20, 80, and 3.8, my minimum is at this t value. It's my lowest, 33.013298. So minimum at that value of t of, and they said to the nearest whole number, so I'm going to say of 4 people. And your answers is a point. Okay? So like I said, a lot of work for really only 2 more points. Again, worth it to get the points. It is. I'm not trying to downplay that. You just want to be managing your time. And so starting to think about how you're going to do that. If you feel like you're really good at doing absolute maxes and absolute mins, then go ahead and do that first, right? You just need to think about how you're going to manage your time. Okay, and then coming back to part C. Part C was worth 1 point. Like I said, in my opinion, it's kind of the hardest one just because it's weird. For t greater than 300, what is the first time t that there are no people in line for the escalator? And so we're thinking here about the t greater than 300, right? At t equals 300, right? The number of people in line in part B we found out was 80. Same thing as I said in part D, by the way, if you found the wrong answer here, but you used, so maybe you found 90, and you used 90 here and solved for t correctly using 90, you could still earn that 1 point, even though your answer is quote unquote wrong, right? You wouldn't get double docked, okay? But so there are 80 people in line at 300. What is the first time that there are no people in line? Okay, well, for t greater than 300, no one is entering the line, right? So the only thing that is happening is we are subtracting from 300 to whatever that value is that we're trying to find, our 0.7, right? Okay, I myself, when I did this particular one, actually set up my integral like this. I wanted to figure out at what point would the number of people leaving the line, that 0.7, right? And so I set it up myself like this. At what point would the number of people leaving the line equal the 80 that I started with? Because then if 80 have left the line and I started with 80, I'd be at 0, right? And so this myself is how I thought of it. I think I actually called it dx if I remember correctly. Doesn't really matter. Right, so there's several ways of setting up this problem is what I'm trying to highlight. And if I didn't touch on the way you did it, I'm more than happy to take a look at your work and say, yes, you are good to go, or help you kind of tweak it to get your answer, because again, there are a variety of ways. Like I said, myself, I did it this way, 80 equals, and then 0.7x. So got 0.7 plugging in the upper t minus plugging in the lower, which is 0, and then I divided the 0.7 underneath, and so you can see that work right here. 80 divided by that 0.7 is the 114. And then this was that many seconds after the 300 mark, and so I added that to 300 to get my 414.285 seconds. Okay? And like I said, it was 1 point for the answer. So, in my opinion, the most challenging part of this problem, again, you might disagree, but I thought that one was weird. Okay. Okay, so these two, like I said, definitely have elements that you won't need to worry about for the AP test. You have one more FRQ set that you are going to be doing, FRQ 8, which the first one on the FRQ 8, I still put in a couple of elements that you won't need to worry about so much, especially the calculator-related elements. But there's a lot of good things to discuss within that first FRQ on FRQ 8. But then the second two FRQs within FRQ 8 definitely have strong elements that could be on the AP test, so important to take a look at. Okay, as always, if there are questions on anything, send me an email.